Hey everybody, let's review how to solve quadratics by factoring, using the square root method, and completing the square. Recall that solving a quadratic is finding the x-intercepts of the parabola. For example, we could have two solutions where a parabola intersects the x-axis at 2 points. We could have one solution where the vertex of the parabola is also the x-intercept, or we could have no solution where our parabola turns up and it is above the x-axis. Now, before we start, recall that when you solve by factoring, the equation must be set equal to 0. So that it has to be true before we can start. So our first problem, we can see that our a value is 1, making this a very easy trinomial to factor. We're going to factor the quadratic into its two factors of x and x. We're going to factor 28 into two factors that also add up to the negative 11. So we know that 7 times 4 is 28, and if we have negative 7 and negative 4, that will give us that negative 11, and it still gives us that positive product of 28. Now that we have our two factors, we set these equal to 0 because we are trying to figure out what can x be so that it equals 0, because that is where the parabola will pass on the x-axis, the x-intercept. So our two solutions, one is positive 7, and our other x-intercept is going to be 4. So we're going to write these with French curly brackets, listing our solutions from least to greatest. Our second example, we can see that this expression, this equation is not set equal to 0. So we're going to add the 6 so that we have 4x squared plus 10x plus 6 equals 0. Now we can get started by factoring. We do have a GCF of 2, so we're going to factor out the GCF 2, and then we're left with 2x squared plus 5x plus 3 equals 0. Now I'm going to use my graphic organizer and multiply 2 times c, give me 6, and then my b value is 5. So we're asking what times what gives us 6 but adds to 5. So that's going to be 2 and 3. So we are solving by grouping here. We're going to rewrite the 5x into 2x and 3x. So that still has that value of 5x. Now we're going to group the first two terms and the last two terms, bringing down that GCF. And then we have to factor out the GCF of each binomial, which on the first one is a 2x, leaving us with x plus 1, bringing down the operator of addition. 3x plus 3, we're going to factor out the 3, and we have x plus 1. Because we have the same binomial here, we know we're on the right track. So we have 2 for our GCF, and then one factor that's a binomial is 2x plus 3. That comes from these two GCFs. And then the other binomial factor is x plus 1, and it's equal to 0. Now we're going to set 2 equal to 0. We're going to set 2x plus 3 equal to 0, and we're going to set x plus 1 equal to 0. We subtract 1, so one solution is negative 1. We're going to subtract 3. We have 2x equals negative 3. We're going to divide by 2. So our other x-intercept is negative 3/2. And then 2 equals 0 is just a false statement. So using French curly brackets, negative 3/2 is smaller. And then we have our negative 1. Our next example, our equation is set equal to 0. And let me back up just one second. This is actually the exact same problem from the previous page, so let's just go to this third example. We have 3x squared equals 18x. And again, we have to have this equation set equal to 0. So we're going to subtract 18x, and we have 3x squared minus 18x is equal to 0. We're going to factor out a GCF, which is 3x, and we're left with x minus 6 equals to 0. And then we set each factor equal to 0, and you solve. To isolate x, we divide by the 3. So we have x equals 0. So 0, 0 is one of our solutions. The other x-intercept is at positive 6. So 0, 6 are the two solutions. So if we were to graph this, here is one x-intercept, and here at 6 is the other. And then our parabola turns up because our a value was positive. Okay, let's move on. Now we're going to solve by square rooting. When you solve by square rooting, that means that there is no linear term. A linear term is like 3x or negative x, where we have a variable raised to the understood 1. So here we have no linear term. So solving by square rooting is simply just solving for x, because we only have one term with an x in it. So we are going to first subtract the 2 from both sides. Then we are going to divide each side by 100. So we have x squared equals 64 over 100. And now we are going to undo the squaring by taking the square root plus or minus. And we have x equals plus or minus. So 8 is going to be the square root of 64. 10 is the square root of 100. And then we can simplify this by a factor of 2 and have 4/5. So if we list these with French curly brackets, negative 4/5 is one root and positive 4/5 is the other. Our next example, we are just solving for x, so we can just simply add 144 to both sides. 144 is a perfect square, so when I take the square root of both sides, we do get two integers as our answer. So negative 12 and positive 12 are the solutions. Here, before we can add 4 to both sides, we have to get inside the parentheses. So this time we have to take the square root of both sides first. So we're going to have x minus 4 equals negative 11, x minus 4 equals positive 11. So we're going to add 4. So you do have to break these down. And so x equals negative 7. And then we're going to add 4. And we have x equals 15. So negative 7, 15 are the two solutions. On the next example, we first have to undo the 3 times. So we're going to divide by 3. We have x plus 6 quantity squared equals 25. Now we're going to take the square root of both sides, plus or minus, and we're going to have x plus 6 equals negative 5, x plus 6 equals positive 5. Isolate the x. One solution is negative 11, and our other solution is negative 1. Negative 11, negative 1 are the two roots. Okay, completing the square. So completing the square is the opposite of factoring, because if you have the constant on the left, you have to move it. So I'm going to add 19 first. So we have x squared minus 4x equals 21. Now, the next step is to ask, is our a value 1? And it is. If it's not, we would factor it out. Now we are ready to create a perfect square trinomial. So to find the needed value comes from taking the b, dividing it by 2, and squaring it. So half of negative 4 is negative 2. Negative 2 squared is positive 4. So since I added a value of 4 to the left, we have to add a value of 4 to the right. Now it's time to factor the left, and this is a perfect square trinomial, so we simply can factor by taking the root of the quadratic, the sine of the linear, and the root of the constant quantity squared, and then combine 21 and 4. Now we're going to use the square root method to solve. We're going to take the square root of both sides. We have x minus 2 equals negative 5 and x minus 2 equals positive 5. We're going to add 2 to both sides. X equals negative 3 and x equals positive 7. So negative 3 and 7 are the two solutions, the two roots to two x-intercepts. Okay, last one, guys. So step 1, you have to move the c value if there is one. If it's just a quadratic and a linear on the left, then you don't have to move anything. So now we have 2x squared minus 4x equals, and when we combine these, we're going to get 96. The next thing we check for, our a value needs to be 1. It is not, so we're going to divide out that 2, not a GCF, just the 2. And you're only dividing out the 2 or factoring out the 2 of the things that are on the left side. So we have x squared minus 2x equals 96. Now we're ready to create a perfect square trinomial. We take half of negative 2, which is negative 1, and we square that, and that's positive 1. Now here's the thing you need to make sure you don't forget. We wrote a 1 down, but this is really a value of 2 because 2 times 1 is 2. So there was a value of 2 added to the left, so we add 2 to the right. Bring down your 2, and now we're going to factor root, sine, root, quantity squared. 96 plus 2 is 98. Now we're ready to solve by square rooting. We must undo 2 times by dividing each side. So we have x minus 1 quantity squared equals 49. Take the square root of both sides, plus or minus. So we have x minus 1 equals negative 7, x minus 1 equals positive 7. Let's add 1 to both sides. We have x equals negative 6, and we add 1 to the other side, to the other one, and we have x equals 8. So the two roots are negative 6 and 8. And these are the 3 methods that we have learned so far to solve a quadratic. And I hope this helps.